Okay, let's start with a bit of update about a change of the plan. I mean, a restructuring a bit of the plan. So, and this is something that also Rob mentioned last week. So we wanted to anticipate and reduce risks on main chain delivery. Uh, so what's the goal? The goal is first to have a main chain deliverable that is containing all the uh, Zendu changes, so all the functionality of Zendu. So um, I mean, the one that are already present in the beta release, but also all the other that are not yet been present. So, for example, the quality management or the seed section withdrawal, the main chain backward transfer request, and so on. So, and going on with this, I mean, there is also the proving system. For example, we want to have the possibility to verify uh, a certificate proof using the final proving system that we will be using on the sidechain side. And this should be a proving system that, as we said many times, must be efficient for recursive proof composition. So we want to be sure to reduce the risks of the main chain delivery. So we restructured a bit the plan to put more resources on the Zendu implementation and on the proven system. And let me say, slowing a little bit down the SDK and the circuit delivery. So we will be able to have a main chain release that can start working on testnet, and also the code audit we'll be able to start sooner. And in the meanwhile, we will continue and finish the SDK and all the changes that are related for the proof introduction on the SDK, and obviously on the circuit side. So and we are confident that this is going to speed up a lot the main chain release, and we will reduce all the risk factors from it. Okay, let's then go back on the specific updates regarding starting from Zendu, and in particular on the certificate quality. We have been doing a first code review session on the certificate quality, and in particular on the acceptance to memory pool implementation. So everything was fine. But some changes were then requested, and currently they are being performed. Next code reviews are going to happen in the next days. Okay, the other big topic of this week is the proving system. You heard me in the last weeks and probably months saying many times about the work that we were doing on the proving system to make it to optimize it from two different standpoints. The first standpoint is, I mean, on the implementation perspective, for example, using GPU for some specific operations that are that can have benefits if run on GPU, but also from the proving system design perspective. So currently, in these months, we have been working on finding ways for having a specific proving system being able to have better performances both during the proof generation and also on the circuit that will verify the proof itself, because you remember we have to do recursive proof composition. And so one of the things that we have been working on in the last weeks is an accumulation and deferred validation scheme that allowed to significantly cut some of the most expensive operations that were needed by the intermediate proofs. And when I say intermediate proofs, I say, for example, let's say, for example, that we have in a block different transactions and so different proofs, and these proofs have to be merged and then merged again, and you have different layers of recursion. And let's say that if you can see it for a whole epoch, you have a big set of proofs that needs to be created and merged. So let's suppose that we can have some part of some specific activity of the prover that can be saved for these intermediate proofs. And doing this expensive part just at the very final proof. So, and if you think about it, if you think in a scenario where you have thousands of transactions, or maybe in an epoch, maybe they can be million or 100,000, and if you save something on a specific proof, it's a very huge benefit. So this is one of the things that we have been working on, and on Friday we went through it, and it seems very, 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 very promising. So we had some numbers. I cannot provide the details for now, but the research demonstrated a huge performance improvement on the recursive proof composition timings, and the numbers showed us a number. Let me say the performances that allowed us to have the transaction throughput that we expect to have on the sidechain, on a single sidechain. So very very happy about this. And on the other side, we have been also working on the GPU optimization, and we moved on also on that part. And also on that part, we had huge, let me say, improvements. So this whole set of improvements allowed us to have numbers that now seems really to meet the goals in terms of transaction throughput that we had for the sidechain side. And so, and the last thing about the proving system is that we have been able to have these numbers also using a proving system without the need of trusted setup. So, and this is a big advantage, because whenever you need to have a specific, for example, customized circuit for any reason, you don't need to have another trusted setup, with a complex ceremony and so on. But instead, with this proving system that we're working on, I mean, this is based on a non-trusted setup proving system. So this is, we're very, very happy about this. And so congratulations to Ulrich and to the proving system team for the amazing job that they did. And you will see in the next weeks something, let me say, more precise, and we will publish the results of what we did. Okay, moving on the circuit side, we had very intense design discussions, and specifically on how we are structuring the gadgets and more in general the code to allow easy circuit customization for custom sidechain transactions. So what are we talking about? Let's say we are introducing a sidechain that, for example, can be a lottery or a stablecoin sidechain. And let's say that we want to track this pool value, and we want to verify and we want to enforce the verification of this pool value in the circuit, because we want to be able to allow seized sidechain withdrawal or mainchain backward transfer request also in mainchain. So we want to prove that the value is something, or other elements that are necessary for allowing the C-section control mechanism. So we identified a design on the circuit side that allow you to introduce a very general concept of state. And so you can see the pool value, the lottery pool value, for example, as a sort of a state, and we designed the hierarchy of the classes and the components on the circuit side that allows you to just focus on the specific state you want to introduce. For example, we say the lottery pool value, and the other part of the circuit are left unchanged. You don't need to modify them. So we're, let me say, putting a lot of effort in finding ways to structure the code on the circuit side to have the developer, even in these complex scenarios, to have the developer's life easier in customizing it. Obviously, if we are talking about a simpler scenario, I mean the circuit that will be available out of the box will be more than enough and no need for customization. But if you need for customizing it, we're working to make it easier and to let you introduce the rules in a more simple way. Okay, and I think that it should be almost everything for this week. So, Luca, back to you.
Thank you, Alberto. Great updates as usual. One more thing is that last week we had it was the halving week, but I'm sure other people will cover these updates. So back to Angie now, and see you later for engineering related questions.
Awesome. Thank you, Alberto and Luca. Let's continue with Jonathan to give us a growth update.